So, more for those of you who are new to the class, to me. Hopefully you have. If you forgot, you were supposed to upload your study set before this time, and ideally as one document. And so some of you who had it in before 5 o'clock actually already looked at. When I look at your study sets, I just look to see that you made an attempt on the whole thing. I don't actually go through and grade it. And so you got a 5 as long as it's in by 6 o'clock and or like a couple minutes after 6, because sometimes there's a little bit of frantic stuff. Then during this time, I'm going to walk through it. You want to make corrections on your own study set because this is your personal reference. So when you go back and do it again, you have your study set to look at. I recommend that you use different colors so you know what you graded with. So this is probably the best way to study for your midterm is to go back and actually redo your study sets. So which of these are never possible? And so we're looking for if you have more than 4 bonds. So the answers are B and C because there's too many bonds. In this one, we have 5 bonds, which is too many. And on C, we get like 6 bonds, it looks like. All right. Saturated. You could Google and get a really fancy answer. Saturated means you have the maximum hydrogens, is probably the technical. It means that you have all single bonds. And yeah, only carbons and hydrogens. So that's what the term hydrocarbon means. It basically means you have an alkane. It's a fancy way of saying we're dealing with alkanes. All right, with that, if saturated means an alkane, saturated is B and D, and A and C are unsaturated. If you have a double or triple bond, you're unsaturated. It's really that simple visually. Next week, I did open the folder for next week. It only has the stuff for Monday in it. We will be getting into the unsaturation stuff. So the notes are posted, and that is the notes for next week for class for Monday and Wednesday, and then it has the study set for what we're going to finish up today. All right, number 4 and the worksheet. So for B, if you have 6 carbons, you double the carbons and you add 2. And so we have 14 hydrogens, so it's the same idea here. For both of these, we get C6H14, so both of these would just be called hexane. That's all I meant by naming it, is 6 carbons we call hexane. Acyclic means it is these straight chained ones. For 32 atoms, there is, like, people come up with this fancy formula, which is pretty simple to do, but I just pick a number and see if it works. So if I have 10 carbons, I double the hydrogens and add 2, and then I add up these 2 numbers and I get 32. So look at that, your teacher is a genius, right? And then on hydrogen is 20, you would subtract 2 and then divide, so it must be 9. Or you say it must be 9 and you double and add 2 and you say, yes, I'm good. 10 is decane, and 9 is nonane. And so I recommend making like a list on a note card of 1 through 10. Actually, making the list will help you, but you're going to use it so much in these first 2 weeks, you're going to know 1 through 10. But having a note card in a handy place, so like when we have our first celebration in a couple weeks, we all have those mind blips for a moment. And so you have it there handy to find instead of shuffling through your paper saying, what was 9 again? All right, on this one, all we're doing is finding the longest continuous chain. And so we're actually going to start down here, and our longest chain would be like that. I didn't ask you to name them, but I'm going to go ahead and name them because it's good practice. Numbering, and this actually answers other questions about which direction you would number in. We would want to start here because we get to the 2 methyls at number 3. So it would be a 3,3,5 trimethyl. And then there's 7, which is heptane. Again, it didn't say to name it, but it's always good to practice. Now, I wanted to point out something on all of these diagrams. This is actually, I love this question that I took from a book that we used once. And if you are asked to draw them like I ask you to do on number 6, and you show me the actual carbons, but you don't show the hydrogens, you would actually lose part credit. So I'll go over that again with number 6. There is some forgiveness in this first week because we're learning how to do it. All right, on B, we're going to start down here, 1, 2, 3, 4, 5, 6, 7. And then we have an ethyl there. So we have a 4-ethyl heptane and 7. So A and B both had 7. 6 and 9 both, I'm sorry, C and D both have 9 carbons, so they're both nonanes. So we'd have 1, 2, 3, 4, and here at number 5, we have this extra piece. And so our longest chain is going to go down, up, and cross like that. And we'd get up to 9. Whichever direction you number from, this extra piece is smack in the middle. And I wanted to do this one because it brings up something I mentioned right at the end of class, but your teacher was tired, so you're probably tired. This is a propyl side group. So a 3-carbon side group, again, side groups are YL, and so we'd say 5-propyl. It's not isopropyl. We'll get to an isopropyl, I think, on the next page. All right, and then this one is 9. If we go down here and across and up, and it is symmetrical, so it doesn't matter where I start numbering. So there's 4, 5, 6, 7, 8, 9. And I did want to also mention, I highly recommend getting a colored pen, the erasable colored pens, because they're really nice to work with. All right, and at 4 and 6, we have ethyls, so 4, 6, diethyl nonane. And again, it didn't ask you to name it, but it is always extra good practice to do that. And it's also, I don't ask you to name it initially because these are a little bit more complicated. And by the time you get through the backside, these are actually pretty straightforward to name. So, all right, so for drawing, I'm going to draw each of these 2 ways. You always only need to do them one way. So pentane, you can do zigzags. So each corner is a carbon, so that would be 5. So either the M or the W. And then at number 2, you have a methyl. If you drew your carbons, 1, 2, 3, 4, 5, what I find is about half of you draw carbons and half of you do zigzags. So that's why I try to show it both ways. And then at number 2, you have a methyl. And then the only thing is you have to fill in your hydrogens. And you can either write them in or you can just show them as dashes like that. And that means a hydrogen. When you do the zigzags, we never show the hydrogens. So a line means methyl. All right, butane, 1, 2, 3, 4. And then we'd have a methyl at 2 and 3. Or you can write your carbons. And a recommendation is that you show your side groups if you write in your carbons in opposite directions. And then you can either write in your hydrogens by like this, writing it in a condensed way, or you can do the dashes like that. All right, and then hexane, so 6 across, and then at 3 you have an elbow because that's our ethyl, and then at 2 and at 4 you have a methyl, or again 1, 2, 3, 4, 5, 6. And if you get more than 6, it does become handy to number, but you don't have to. So a methyl at 2 and 4. Oh, I did that funky. And then at number 3, we're going to have an ethyl. So, right, didn't plan that very well. And then you would show your hydrogens. So again, when you show your hydrogens, if you show the carbons, you must show the hydrogens somehow, either writing in the H's or you can show dashes. Just be careful that your dashes don't start running into side groups. So try to keep it separated as best as possible. Any questions from the first page? From the homework, the study set?
I have a quick question.
Yeah, go ahead.
On number C, you have an E by that ethyl. Do you need to write that in, or was that just
No, that
for
was
us
just
so we
me.
could tell? Okay.
Yeah. Yeah.
Perfect.
Yeah. No, you don't
Okay,
have
thanks.
to at all. Anybody else? I just kind of keep going unless somebody stops me. Another quick comment for you guys. Last term, I had a scanner. My scanner's in Oregon, and so I would scan the study. After I went through the study set, I would actually scan it and like within a day or two actually post the answer key in case you wanted to go back and look at stuff. I don't have that capability right now, but I do videotape, so you can always go back and look at that. All right, we're going to number this one. It is going straight across. Before you number, you just want to always say, am I going to start on the left or the right? And this one, we're going to start here, 1, 2, 3, 4, 5, 6, which is hexane. And this extra piece is a methyl. Now, back to the question somebody just asked. You don't have to number, but the students who do number get it right. And so like on worksheets where I do look at it, and definitely on the celebration, I like to circle my side groups. It also helps with teaching to be more clear with what I'm doing. All right, this one we're going to start numbering over here. So 1, 2, 3, 4, 5. And then we have a methyl there, so 2-methylpentane. This one we want to start numbering over here. So 1, 2, 3, 4, and you do want to curve down. So it's the same answer, 2-methylpentane. So a lot of people initially miss this one because you forget this ability that you can curve down. So you do want the longest continuous carbon chain. All right, and then the next one, 1, 2, 3, 4, 5. It doesn't matter if you start on the left or right, you get the same answer. So 2,4-dimethylpentane. We're going to do a little bit more challenging naming today when we get to the notes. And so there are some really wacky rules we'll run into, and just kind of embrace the rules as we get to it and realize the study sets are there to refine it. And something we discussed last class, and again this one, you do your worksheet, but don't submit it until like after we've gone through the study set. So if there might be a few things that will help you to refine things that you might want to go back and fix. All right, more naming. This one, again, it doesn't matter, it's symmetrical. So you can start on the left or right. Visually, it can really help to circle, okay, those are my side pieces. Sometimes as we get into more complicated ones, you can check off your side pieces as you name them. Back to the question somebody asked me, I just write the E and the M. Alphabetically, when we name and we have different types of side groups, the alphabet determines the order we write it in. So we put the ethyl first. So for ethyl, a reminder, we have commas between numbers, dashes between numbers and words, and then another dash, 3,5-dimethyl. When you have more than one, you have to tell me how many there are. And we had 7, so heptane. All right, the next one, you're going to want to start over here. And so somebody's not muted. I don't know who it is, but if you're not muted, just mute yourself because there's background noise. So you're fine. Sometimes we're just not aware of it. We want to go the side that will get to more side groups first if the first side group is the same number on either side. That was really awkwardly worded, but yeah. All right, so at number 2, we have methyl. So we have to say there are 2 of them. And then at number 5, we have methyl. So 2,2,5, trimethyl hexane. All right, the next one, we're actually going to start down there. So this guy, you're never going to have a methyl at number 1. If you have a methyl at number 1, you didn't find the longest chain. You can never have an ethyl at number 2. So you can ponder that. Actually, with an alkane. I should put that there because when we get into oxygens, we're going to see some things happen. So 1, 2, 3, 4, 5, 6. There's my methyl, just one side group of that methyl. So 3-methyl hexane. I'm okay with you leaving a space between your side groups and names. Technically, it all runs into one big long word. All right, this one also curves down here. So 1, 2, 3, 4, 5, 6. So our methyls are at 3 and 4. So a 3,4 dimethyl and hexane. So questions on those? And again, I mentioned I used to not put the zigzags on initially, and then when I started using the zigzags, students freaked out. So I put the zigzags initially, and I found the students, some people preferred, everybody has a preference, but it's more that you're able to do either way. I actually like the zigzags. So 1, 2, 3, the zigzags are really nice to number. That would be our 7. So, and this is a methyl at number 2, so 2-methyl heptane. And this one, I guess I like the zigzags because it's easy to see which side, if it's lopsided. So on this one, that would be my number 1. And so we have a 2, 3, 4 trimethyl. Again, as we're going through it, if you missed one, that's okay. That's why you're making corrections so you have it. I'm just looking on the, when I look at your study set, if you did it. The worksheet, I do look if you have it right, but again, you can have me look at it or walk through it with me after class or before class. All right, this one, there's my 1, 2, 3, 4, 5. And so at number 2 and 3, I have a methyl, so 2, 3 dimethyl. And 5 is pentane. So with the zigzags, it really is nice to number. And then this one we have 1, 2, 3. You can also number every other one. Sometimes that's nice, as long as you know how to count every other. So 7 is heptane. And at number 4, so again, this is an ethyl, this is a methyl. So the ethyl comes first. You don't have to put the E's and the M's there. That is just, that can help some students like that. 2-methyl, and then heptane. And again, some of these have crazy long names, and I don't give you much space, so you just start stacking the name like that. That's not a big deal to me. I'm not a real organic chemist, so. All right, and more of these. So to me, when I look at cave drawings, so I've worked all of you, if you ever go and look at like cave drawings at Mesa Verde or somewhere, you're going to start seeing organic molecules. You're going to tell the people you're with, hey, look, there's a 2, 3 diethyl methane something. Okay, so we have 2, 3, and 4. Yeah, 2, 3, 4 trimethyl pentane. A quick comment for you. It's not a big deal this first week, but this ending ANE, next week it's going to change. And so it's going to be really important that that I can read your writing. We all have different levels of penmanship. My penmanship is by no means perfect, but it is something we just need to be careful with. Right, on the next one, we have 1, 2, 3. Oh, I didn't really do that. All right. So let's just go with hexane. It is a hexane, and that would be an ethyl. So we have a 3-ethyl, a 2-methyl, and that is actually the correct name. I'm going to come back to that one. Right, on C, it curves. So you do, we should use a different color. 1, 2, 3, and then 4, 5, 6, 7. So it is actually a heptane. So do watch out for that. So we have a 4-ethyl, 3-methyl, and then heptane. And then the last one, on D, 1, 2, 3, 4, 5, and we have to curve down 6, 7, 8. So we can get an octane from this. And then that piece at number 5 is an ethyl. Again, you don't have to circle them, but it can help. And at number 2, that's a methyl. And sometimes one of the things is we get into sometimes when you get ones that are really crazy and have lots of extra pieces, it can help to circle as you name that piece so you make sure you got all the pieces. Those are just things that can help. I want to go back and look at B unless somebody had a question. And it is something I'm going to get into today. This is the correct name that I gave it. It is something that can happen. I'm going to use the blue. If you started down here and went 1, 2, 3, 4, 5, 6, you get 6 also. So sometimes there's 2 ways you can go and get the longest chain, and there is only one right way to do it. If we went that way, we get this piece as a side group, and that would have been an isopropyl. Now, there's one way of thinking saying, well, it would then be a 3-isopropyl hexane. And it seems like that would be cleaner because it's a shorter, we don't have all these pieces. But the rule is if there's 2 ways you can get the same longest chain, you go the way that breaks it into more side groups. It's a little bit of a tedious rule. We're going to run into it again today, but I just wanted to mention it on this. So if there's 2 different ways that will get you to the longest number of carbons, you go the way that breaks it into side groups. So my pink way is correct. And so any questions? I'm going to pause and